Hello everyone, in today's video we'll be discussing remainder and factor theorem in IB Math AHL. Now let's get started to the video. So suppose that I have a polynomial of x cubed minus 2x squared plus 5x minus 3 divided by x plus 5, okay? Now, if we were to divide this by using long division, it would be something like this. X plus 5, x cubed minus 2x squared plus 5x minus 3. And if we were to divide the leading terms, x cubed over x would make x squared. Multiply this, x cubed minus actually plus 5x squared, because we multiplied this term by this and that, okay? So, and then we go ahead and minus these, okay? So x cubed and x cubed cancel out, and minus 2x squared minus 5x squared would make minus 7x squared. And then we bring down the terms that are left over. Okay, so I'm just going to go through this real quick because this is not our main concept, but negative 7x squared minus over x would be negative 7x, multiply that, negative 7x squared minus 35x, okay, minus that, minus goes on, okay, then we have 5x minus 35, which is 40x minus 3. Divide the x's. It's going to be plus 40, then 40x plus 5 times 40 is 200. Okay, so we divide 40 and 40 cancels off, 40x and 40x cancel off, and we are left with a negative 3 minus 200, which is minus 203. Okay, so the term that we are left over with here is going to be our remainder, because hypothetically we cannot divide this no more by this, because the coefficient, the power of the leading term is larger than the power of the leftover here, because x to the power of 0, this is x to the power of 0, and this is x to the power of 1. So when your divisor's power is larger than what you have left over here, you have to stop the division process, and we call this the remainder. We call this the remainder. Now, what if I told you we could find the remainder easily without having to do all this work, okay? And here, what the remainder theorem comes in handy, okay? So we go here, remainder theorem. So what this states that if we were to do, if our divisor was divisor, this is the divisor, by the way, divisor, the result over here that we get is the quotient, or q of x, and this is the remainder, okay? So, and this is the dividend, by the way, dividend, okay? So if our divisor is, let's say, x minus c, then our p of c, which is our polynomial, let's just write p of x or p of x, because hypothetically this is a function, right? P of x, then p of c would be the remainder, okay? Let's say that this is d of x, our divisor, and this is p of x, okay? So now it makes more sense, okay? We say P of C is our remainder, okay? So let's actually test this out, okay? Our P of X is this, and our D of X, which is our divisor, is this. So if we were to say, okay, what is C here really? We see C here is actually -5, right? Because here we have a positive sign, so negative would make positive, okay? So we can say that P of -5, let's check this out. What is P of -5? I have to have my calculator for this because this might be a little bit complicated. P of -5 would be -5 cubed minus 2 times -5 squared plus 5 times -5 minus 3, okay? So let's go ahead and calculate this. So -5 cubed would make -125. So 5 times 5, 25 times 5. And minus -5 squared would make 25 positive. So minus 50 plus, actually no, minus right over here. Minus 25 minus 3. Okay, so if we were to plug that into our calculator, right, really quick, without having to do a lot of work, we see actually we don't have to use the calculator. It's really simple. So we see -175, and we see -200 and -203. So you can check this out on your calculator. This will give you -203, what we had right over here, okay? So we did less work right over here. However, we achieved what the remainder is, okay? This is only useful when you're trying to achieve the remainder, okay? So this was simply the remainder theorem, and here's a real proof on why this works and how this works for all numbers. Let's get this up right quick. Okay, so we can represent polynomials in this form, every polynomial. We can say polynomial P of X equals D of X multiplied by quotient plus the remainder, okay? The remainder here is independent, okay? So if we say our D of X is X minus C, okay, a linear divisor, then we can say P of X equals X minus C, in brackets like this, multiplied by Q of X plus R, okay? So, and if we substitute this with X with C, we would get C minus C multiplied by Q of C plus R. And we know that C minus C is 0, okay? So P of C is left with 0 multiplied by Q of C plus R. And anything multiplied by 0 is 0. So P of C is R, which is the remainder. This was a quick proof of the remainder theorem right over here. Okay, so now let's discuss the factor theorem. Factor theorem, okay? So we said that P of C, if D of X equals X minus C, then P of C would be the remainder, right? Remainder. But what if the remainder is equal to 0? And that's how you know something is a factor of something, okay? So if P of C would be equal to 0, then you know that X minus C is then X minus C is a factor of P of X. And P of X can be literally any polynomial, okay? So let's have an example right over here. All right, so here's a question from the IB Math AHL textbook. So we have a polynomial. Let's write it down here. P of X equals 2x cubed plus x squared minus 15x minus 18. And it says that use synthetic division to show that x minus 3 and x plus 2 are factors of the polynomial. Now, of course, we're not going to use the synthetic division to do that. It takes a lot of time. Instead, we're going to use the factor theorem, okay, just to quickly get through this, okay? So we said that our divisors are, D of X's are x minus 3 and x plus 2. So we assume that these are factors, meaning that if we would do p of 3, it will be equal to 0, and p of negative 2 would be 0, okay? We assume this, but let's actually check this if it is really true. So p of 3 is 2 times 3 cube, 2 times 3 cube plus 3 square minus 15 times 3 minus 18. And this is equal to 2 times 27, which is 54, plus 9 minus 45 minus 18. And yes, this is really equal to 0, okay? Let's check p of negative 2. So this is true, okay? This is true. Because no 0, with 0 as a remainder, that means it is factor of it, right? Okay, so if I say that 12 divided by 2 is equal to 6 with no remainder, then I can happily say that 2 is a factor of 12, right? I can just say that. So let's just get this out of our way, okay? So let's check p of negative 2. So p of negative 2 is 2 times negative 2 cube plus negative 2 square minus 15 times negative 2 minus 18. And this is equal to 2 times negative 8 times negative 8 plus 4 plus 30 minus 18. And this is 16, negative 16 plus 34 minus 18. And this is equal to 0. So it is true. It is true. So we can happily say that, okay, x minus 3, and x plus 2 is a factor of our p of x, right? But we can also write it like this. If they are a factor of p of x, right, we can say this: x minus 3 multiplied by x plus 2 multiplied by quotient, some number, okay, will be p of x. Because notice that we must have 3 roots because it is a 3 power to the 3 polynomial. It's the polynomial's power is 3. Okay, so we must have the third root, and the third root is this. And to find that, we will have to divide. If we expand this, it's going to be x cubed plus 2x minus 3x minus 6, x squared minus x minus 6. So it will be equal to this, alright? So if we say x squared minus x minus 6 divided by 2x cubed plus x squared minus 15x minus 18 minus 15x minus 18, right? If we divide this, we're going to get x cubed over x squared is 2x multiplied by 2x cubed minus 2x squared minus 12x. Okay, minus 12x, divide that. And we're going to get 3x squared minus, we're going to get minus 3x, okay, and minus 18, just bring that down, and x squared, it's going to be plus 3, it's going to be 3x squared minus 3x minus 18, and if we just minus them, we get 0. So we have the final quotient right over here, and that means that x minus 3 times x plus 2 times 2x plus 3, and also we cannot forget about the leading coefficient, which is 2. We have to always write the leading coefficient in front of the brackets, and this will equal to p of x. And so you can prove this yourself by expanding the brackets. You can prove this by expanding the brackets to check your answer. But this should be equal to p of x, because as I said, they're all factors of it. If you multiply the factors, you eventually end up getting that number. Okay. Alright guys, so that was it for the video. I hope you understood everything that you needed to. Make sure you subscribe to the channel to support it. And make sure you leave a comment down below to express your concerns or any questions that you have. Make sure to like the video and share it with your fellow classmates. So that was it for today. Bye. See you next time.